Welcome to the lab. We were just a few minutes ago in the lecture. Let me emphasize on a very important point for the lab, okay? It's very important that you guys attend the lab, because especially now in this online thing, it's really more of a step-by-step process. And if you miss a step, or if you don't understand the step, you will have difficulty finishing the lab. And so it's really a process, and that process has to be from the beginning to the end. It cannot be picked up in the middle or somewhere else or something like this. So this is more of a systemic attendance thing. I'll try to keep the lab sessions as focused as we can. But today, actually, we're going to talk about more of the process than anything else, okay? So let me jump right into the lab for today. Somebody asked me when we were in lecture, actually before we started the lecture earlier in the morning, earlier in the day. So probably you will not find it in the recording, because we only record when we meet. And the question was actually before, when we actually started the class, I should say. So the question was the simulations, okay? What kind of link should we have for the simulations? Basically, this is how it is for me in this class. Oh, I'm sorry, I did not even turn on my camera. Nobody, sorry about that. Okay, so this is basically how I do things in this class. Most of the simulations, I make them myself. Basically, I work on them and make them and provide you for the link for them, okay? At this point, I don't see any simulation coming from outside of the tab that I give you. Now, if down the road, somehow, for example, we find the simulation that works outside, I'll give you the link to that. For everything, I'll give you the link. Everything actually is contained in the lab instructions themselves. So if there is a link outside, the lab instructions will tell you to go somewhere. If there is something else, the lab instructions are going to go tell you somewhere else. Now, here is the thing. For the labs, you have what is called the PDF fillable files. And PDF fillable files, I would recommend you take advantage of them and use them instead of doing other things. Otherwise, you'll find yourself typing and formatting and spending a lot of time basically left and right, whereas the form itself is ready to go. So we're going to learn today how to do that and see how we're going to do that. And down the road, if you have questions related to the form or the lab, please do ask them. I want everything to be clear to you guys so that you do this lab. This lab does not require a simulation. As a matter of fact, it requires you do things, okay? You have to get things done on yourself, okay, by yourself. So, Carlos, you have a camera on or something? Okay, good. No, we don't. Okay, good. So basically, as long as we are clear on the process, we should be in good shape. For some reason, I'm missing a few people who were already in the lecture. For some reason, they are not here. And that is not something I would recommend. This is actually more important in terms of the following step by step. The other one, you can always find answers in the book and basically ask me later on, but this one is actually critical. Okay, although the attendance on that one also is not a choice, because you have assignments related to attendance. Okay, and that's probably one of you guys is sending me messages on that. Anyway, let me get into the lab itself, and we will see how that works. Okay, let me first of all open it, so that we are all on the same page. Modules. And we are in Coulomb's law.
Professor, do we follow you along? Do you just want to...
I can have you, yes, you can follow me, or I'm going to start talking slow. We're going to do the steps. And again, you can come back to this session here if in case it's not clear, or ask me inside the discussion for this lab. It's going to be separate from the lecture, okay? So let me share my screen with you guys so that we are on the same page. Okay, I want everybody to right-click on that link if you are on a computer. If you are not on a computer, you have to do that as step number 1. So you right-click on the link, and you're going to say, save link as. I have Firefox, so it gives me this option. So the first thing I'm going to do is save link as, and then it asks me, you want to save lab01 underscore coulombs underscore law underscore report underscore form.pdf. I'm going to save it somewhere on my computer where I can find it. My suggestion for you guys is that you create a folder, call it labs, okay? And you save these forms on the first, on that folder, okay? So that you have all of your work in the same area. Down the road, that constitutes your lab, whatchamacallit, where you put your lab report, basically book or something like notes, okay? Does everybody have clicked on that link and downloaded the folder? Because if you miss this step, many things will go wrong, okay? And I will tell you what those things can go wrong, okay? Because some of you will encounter those things that go wrong, probably even if you do this step. So you really have to be careful with the initial step. Can I get that you're done with it? Okay, when you go to your modules, under modules, you're going to see Lab 1 Coulomb's law. Click on the link under Unit 2, because we are in the basically the second one. You should find it there, okay? You should find it there. It's also sometimes under syllabus, under assignments, you will find it there. And there are also things to do, you will find it there. Does everybody find it, or am I talking nonsense? Because if you guys don't have it, we have a problem. We cannot do this lab, because Jacob was asking. Okay, good. At least one of you found it, so it must be there. Faz, where did you find? Which link did you find it? Did you follow it?
It's on the right hand side where we go to courses.
Okay, very good. So if that's your easy way of getting things, get it from there. Click on it and you should open it. Usually, yeah, it's a good idea to go to modules link, which is the second link from the top under home. Click on it and you will see all of your assignments, homework, and everything else to go with it. It's not just this one. There are other things in there too. Okay? So if you found it, I assume now that you right-clicked on it and you saved the link. This step is critical, okay? Because if you click on it and you open it, chances are it's going to be opened by your browser. Now, everybody thinks that they can open PDF files, and they do. There's no problem with that. Microsoft Edge thinks it can do it, and it does. Firefox thinks it can do it, and it does. Chrome thinks it does the best thing at it, and it does. Safari thinks that it's the best at these things, and it does. All of them claim to be the best when it comes to handling PDF files, and they all do. Except this is not a regular PDF file. This is a fillable file. Most of them, they will falter in saving these files. They'll give you access to the file. You start typing your work. You did so much amount of work on this file. Now you think you're ready to go, and then you send the file. And it's still 5 minutes probably before the deadline. You finished everything. Everything looks immaculate as far as you're concerned. And you send the file. The file is not saved. The file is a blank. I receive a blank file on my side, and I ask you to go and look at your assignment. Sure enough, when you yourself click on it and open it, you find everything is gone. Nothing is saved, because they are not basically capable normally of handling this type of files. So you have to open it, and you have to get it through the Adobe Reader. I know we talked about, this is a link actually. I'm sorry, why it's not broken in here? So let me get the, fix this thing quickly in here. This is a link. Let me edit this link. You have to get the Adobe Reader on your computer. You have to access the Adobe Reader to handle this thing in here, okay? So I'm gonna create a link, external link, and the link is actually HTTP, I think get.adobe.reader, no, get.adobe.com, I'm sorry, /reader. Let me make sure this is the correct link, because I think I memorized it now. Let me open it with another browser.
Professor, what type of What do we save it as? The Adobe Acrobat document? Is that it or no?
Yeah, that's fine. Yeah, save it as that. Okay, don't change the type of the file. Okay.
Okay.
Yeah, don't change the type of the file. Leave the name of the file for your convenience the same. The only thing I'm asking is that you save it on your computer. Don't leave it on Canvas. Okay. Now it's a link. This one is actually a link. So to get the reader, okay, for you guys. For some reason, the link was broken for somehow. Okay. So this is the where you go and get the reader. Some of you, at least probably in this class, or I don't remember if it was another class, they said that when you go to this link, you will find a bunch of other things there. Don't download them, just download the reader. I think that's a good recommendation. Just stick with what you need until some other day you decide you need something else. You go there and you download things because you have a bunch of things to click on. If you don't have the reader already installed on your computer, download the Adobe Reader on your computer, okay? Now, granted, there is a new version of Reader, but that's fine. It should work. All of them should be able to handle it. So the first thing, question? Yeah. And check the boxes. You don't want the, okay, that's a good recommendation, Christopher. Okay, that's a good way of doing things. Okay, so make sure that you only have the reader. So the first thing you did was download the file, correct? I assume by now everybody has the file sitting somewhere on his or her computer outside of the canvas. Now, read all the instructions. We're going to go through this. We're going to go meticulous about this one, especially the first one. Then complete the activities you asked to do. So now go through step by step. If you're asked to do the background information, go through it. Try to understand what this topic is talking about. And then, because at some point you're going to formulate a hypothesis, so you really need to gather that background information. So you need to really understand what's going on. Get the reader if you don't have it. If you have it, then skip that step, okay? Save the file on your computer when you're done. So if you don't have the reader, save it, okay? Okay, complete the activities means that fill whatever thing says. You will find that the first thing you need to do is fill your name. You'll get a point for filling your name. You're going to lose a point if you don't fill your name, okay? I have received many, especially the things that I used to receive, and they are completely anonymous from something, the best motorcycle at gmail.com. Here is my lab report. And I have no idea what that Gmail address is, and I have no idea what the class is. I know from the lab context, but I cannot relate that to a specific name. It's a generic Gmail address. So again, you're going to fill it. First thing is put your name on there. You're going to lose points. So the first thing is start filling the file, follow the instructions, and when you're done with that, save the file, okay? Do not assume that the autosave is on your computer. Save the file. Now, close the file after you save it, and open it again just to check that the file, what you did is still there, okay? That is because, like I said, you're on the deadline, you still have a few minutes or a few hours to finish this thing, and the file is not saving for you for one reason or the other, okay? Make sure it saves there. Then submit it to Canvas. If you want to edit it, if you want to change things, for example, you decided, you know what, I don't like my answer to question number 3, so I'm going to change that answer to question number 3, or I want to reformulate my conclusion. So you're going to go back, open the file, make the changes, save the file, close the file, open the file to make sure that your change is basically persisted. So that's basically how you do things in here, okay? One of the problems with the browsers in general, they're stateless. They don't save anything. They don't, basically when you go from session to session on a browser, unless you have cookies, you really don't know what happened in the previous session versus this session. But in this case, you have it on your computer. So it says in the Adobe Reader, okay, Jaden, I need to know why is that, okay? Because even the IRS uses these PDF fillable files to do this. So if you're having difficulty saving this file, please, I need to know. Oh, man. What? What is the solution, Christopher? What happened? You're going to change the name? Okay, I think I probably used a different editor for this. Is a PDP. Okay.
I'm having the same problem too, Professor.
Okay, well, this is new because I
Uh,
think I used different version for this one. Look, if this is a problem, and I know exactly what the fields are causing the problem, I think the two images there, if this is a problem, then I'm going to re-edit this file, okay, and upload it back to you guys, okay? It's the reason why it was saving earlier probably on my computer was the fact that I had it, I have the other one.
Where is the subscription?
The Adobe Reader requires subscription, isn't it? Oh yeah,
yeah, it
I think,
does.
yeah, it's a free subscription. Anybody can have the reader. Uh-huh.
Well, to edit and to use other things.
Oh yeah, the college. No, I don't know. Do you guys have free access to the suite, the Adobe Suite thing?
I don't know.
I have no clue.
Okay.
But
Well, that's
if
yeah.
you use the PDF editor I linked, it's completely free. I've been using it for a year and a half now.
Okay, I didn't know that. Okay, that's a good link to have. So I'm gonna download this thing in here and play with it because I have Sandbox on my computer to see if that's going to work. Okay. Okay. Well, if that's a problem, that's a problem. Okay. So we'll have to find a workaround solution to this thing in here. Okay. Because I did not have a problem with any of my other classes. I mean, I am teaching the lab for the other class, Physics 11, and they have the file, and they've been submitting the file. Okay. And I think I know because this one, most of the times I use Adobe by itself, Acrobat, to edit these files. But for this one, I had to add two picture fields, and the two picture fields require something called lifecycle. And lifecycle did not ship with this product. It shipped with the earlier versions of Adobe Acrobat. So I downgraded my Acrobat and removed that subscription from the college just to see if I can get this image fields in there. So if that's the case, I'm going to remove the image fields and basically have you guys submit the pictures separately by themselves and re-upload this file hopefully tonight or early tomorrow morning. Okay. Does this sound like it's a good plan, more or less, to proceed from here?
One moment, Professor.
Okay. In any case, the worst case scenario that we're contemplating is that you guys are going to submit your answers to the questions, because they are questions basically, no more. Okay. You can write a text file, TXT file, and basically just question one, answer question two, answer basically, because there is the rubric underneath. You guys look at it. It says the rubric in here, how these things are graded. We're going to go through these things. Your name, the objective, and what you need in the objective. Question one, what you need in it, and the sketch, which requires a picture by itself. That's why I had to change this, what I normally do for this kind of PDF fillable files, and I invoked the life cycle. Or is it life cycle? I forgot what even it's the name of the product. Is it life cycle or is it live? Yeah, it's called life cycle designer, Adobe life cycle designer. That's an old version. They stopped making it with the Adobe version 9, and we're way past that now. We're in the cloud. Anyway, yeah. What else? Even now, everybody thinks they can do forms. Then you have a table, okay, with 8 entries. So you have questions 8, and then you have the conclusion, the requirement for the conclusion, and then you have a final picture in here that I was going to talk to you about, and that is the setup, your own setup, basically. So, barring these technical things, which we can overcome either by fixing the PDF file itself or having you basically submit a text file, either way should work fine, okay? Let's get through this lab in here. Can we proceed? Yes?
Yes.
Okay. So let's get into the lab in here. Like I said, this lab normally is due in a week time. Every lab I assign is due in a week time, meaning that today is the 31st. A week from today is going to be, if I can get this one, the 7th, Monday the 7th. But because the 7th is actually a holiday and we don't have classes, we're going to have it done on the 8th, the day after, which is by 11 p.m. by almost midnight. I mean, 1 hour before midnight. So you should be done by then with this lab, and you have answered all the questions and did all of the activities related to it. So from now on, any lab that we assign, we go together through it. You have exactly 1 week to complete. The only exception is when we have a holiday like today, for example, like this time around. Okay. So that's something that you have to keep in mind. And the rubrics should be immediately appended below. All the labs will be graded 1 point for your name. Missing the name will lose that point, so you don't forget that. That's critical for your lab report. Then all the labs will have objectives that are worth 3 points, and the objective stating the objective of the lab in 2 or more sentences. So you can have 10 sentences if you like, but they have to be accurate. They have to be what the lab wants to do. Usually I recommend do not start with the objective of the lab. Try to read through the lab, see what the activities are, what you're asked to do, and then come back to the objective and formulate it based on what you understand, basically of what we want to do in here, okay? So this is something in here. Sometimes it's explicitly stated in the lab instructions that this is what we will be doing. It's fine. You can put that verbiage or make it in your own word based on what you understand in there, okay? You lose 2 points if this is not complete or ambiguous. I mean, related to the topic, but ambiguous. Or you lose all points if in case you forget it or skip that part completely. Okay, so again, you can follow the rubric basically and go through these things. All the questions in all the lab reports are worth 2 points. Okay, make sure that they're accurate using complete sentences. You cannot come to a question and the question is asking, are they proportional, for example, and you tell me yes or no. Those are not complete sentences, so I'll assume you did not answer the question. You have to relate to the topic. This quantity is proportional and the constant of proportionality is so and so. So do not do those short answers that are not complete sentences. So you have to use full sentence, very clear, very unambiguous about your answer. Also, if there are numbers asked in the question, each number must have a unit, okay? It's a measurable quantity, unless it's a ratio of 2 quantities. For example, I'm trying to find the ratio of the force of gravity over the force of, for example, electrostatic force. That's a number, okay? That does not have a unit. Whenever it's applicable, the unit is a must. You cannot give me a number in an answer without units. You're going to lose points for that. In general, even in the exams, by the way, you're going to lose 2 points for the units, and you're going to lose in this specific case only 1 point in here for the labs, okay? And it's going to apply each time there is a case for it in this case in here. So units are what makes the difference between physics and math. And we're doing physics, we're not doing math. So you have to pay attention very closely to units, especially when it comes to lab, more so in lab than anything else, okay? So you have to have that in mind. All the questions there are going to be graded like this. So this is not, so from this point on, you're going to be asking about the rubric, how am I going to be graded? You know exactly how you're going to be graded. If there is a table, and there is a table in this case, you will have, depending on the entries and the type of the entries in here, okay? In this case, you have 8 entries. So in this case, you're going to get 8 points. Partial credit for missed or incorrect data, okay? And no marks if you miss the entire table or you put some nonsense data in it, okay? Again, you're going to lose points for units in here, okay? If you're not careful enough with this thing. Most of the time, since it's a pillable PDF files, you don't worry about the units for the tables in this case. But if we're doing it face-to-face, I'm going to also take points for the lab data entry if you miss the tables or something like that. All conclusions are worth 5 points. They are more than actually the objective, because somehow they relate to the objective. In your conclusion, you have to check your objective and your hypothesis. Do you meet it or not? And with what type of accuracy did you meet it? What kind of support did you need it? Did you meet it? And that is where the lab data comes into play. That is where your observations or your measurements come handy. So in your conclusion, you have to include that, okay? Usually I'm looking for more sentences in here. So 3 or more sentences, and there is actually showing an understanding of these things. 5 for partial, for full credit, 2 points for partial, and no credits for whatsoever for the other one. For this specific lab, you're supposed to include 2 pictures. 1, or 2 graphs. One, which is a graph, really, a sketch by hand. By following, basically, you're asked to find you're going to put in the x-axis the strength of the force, and the y-axis you're going to put the distance. Basically, you have Let me explain a little bit. We're going to go into the lab, okay? Let me pull one of them in here. This is a clear tape. This is what you will need for your lab, okay? A clear tape in here, okay? So you're going to include 2 of this, okay? You're going to have another one, and I'm putting my hand in here, and I'm putting my observations in here. You're going to bring 2 of this and put them closer to one another and think how this force of attraction or repulsion, depending on what's going on in your case, is related roughly. You don't have to be accurate for the chart, for the graph in here, with distance, okay? It's asking you specifically not to have them at 0 distance. You cannot have them touch, okay? Close, but not touching, okay? The last picture that I want from you is a picture of the setup for your lab, okay? Let me start with that one last, because that's critical. If you take a picture, and I just took a picture actually when we went in the break with my cell phone, okay? If you take a picture with your cell phone, a default picture will be a huge picture. My suggestion for you is, if there is a mode on your phone that when you're taking pictures, I'm looking at my phone trying to see this thing. I have an iPhone, by the way, and I have a Windows phone. I have also an what is that? An Android phone. Okay. So let me go into the pictures settings in here. And you have different modes. So you try to go into the settings and lower the settings of this. I don't know. I don't really like very much this kind of phone. Let me see here. Does it have anything for the settings? Okay. Here is what I'm trying to say. I couldn't find it on my phone. Probably there is a way. Lower the resolution of the phone. Do not run it super high. There are some of them that are specific for web, at least on the cameras, it says web mode, okay? Use that, okay? 640 by 480 is plenty resolution for what we need in here. However, when I took the picture earlier, like I told you, I took it with my phone, regular settings, which gave me a picture of 1.77, which is 1.8 meg. It's a huge picture. If I'm going to scan all of my entire work and make it with that resolution, and if I have, let's say, for example, 14 pages, each one of them has almost 2 meg, you're looking about 25 meg of images. And if I start uploading my work, let's say, for example, oh, the deadline is 11 p.m. and it's already 10:30, so let me start uploading. It takes forever to upload that work. It may exceed the 11 p.m. deadline. So my suggestion for you is lower your resolution as much as you can, because it's going to work, okay, even with 640 by 480. The rule of thumb here is the following. Take a picture with the lowest resolution you can, then look at it on your screen. If it looks fine to you, it's going to look fine to me. So it's going to be readable to me. Now, if it looks fuzzy, most likely it's not the resolution that messed it up. It's probably there is a motion or something like that when you took the picture. That is really what messed it up. So you have to retake the picture. Even if you put it at the highest resolution, that is going to be a problem. So when you take a picture, try to have it as readable as you can so that you can read it. If you can't read it, I will not be able to read it either. So that's basically in terms of the picture taking. I have a software in here called GIMP. I know some of you probably have Photoshop that can actually do the same thing. This is actually what I did earlier when between sessions, basically lecture and lab. I took, like I said, with this high resolution, I took the picture, uploaded it. Let me stop sharing to show you the difference between the 2 pictures. And you tell me if there is any difference whatsoever. At least to me, I did not see that there is much difference in here. Okay. That's not the class. Let me get the class, Physics 4B, Labs. Okay. Okay, let me start sharing that screen in here. Share. Okay, so this is the picture that I'm asked to upload, okay? And this is the picture of, do you guys see it? Yes?
Yes.
Okay, very good. So this is the picture that I took earlier for my setting, okay? It asks me to make a to take about an 8 inches of blank, basically. What do you call it? This one, transparent tape, and you will need that anyway for your lab. What happened to mine? Here. Okay, you will need it for your lab. Okay, this is usually not expensive. You can get it from a 99-cent store. Try to get not the brand. Okay, I know it talks about the Scotch tape and all of that. You don't have to go for that brand. Get a 99 cents or cheaper one. Okay, that's useful for that, and you might need it for some other purposes because this is too much for what you need for your lab. Try to also need to get a string in here. I have this string in here. Oops, this one. Try to get any kind of a string because at some point you're going to be hanging them with the string. Not too long. You can even use the one that basically for clothes, for sewing clothes and anything, things like that. There is no specific type of string. If we were
Would a shoestring work?
Probably yes. Okay. Yeah, as long as you can hang it in here, because at some point any string should work. Okay. But not to have it too heavy, because if it's gonna be too heavy, and I don't know what kind of strings you have for your shoes, they might interfere with the forces there. Okay, so try to make it as light as possible. Okay, the one for the sewing machine would work perfect. Actually, it's good. Okay, my point about this picture in here, if I can, so I'm going to go to another picture in here. Let's see. Okay, so for some reason, yes, that is not responding to me. So when I share the screen, it doesn't respond. Is that what it's telling me now? Okay. My point in here is I used GIMP. Oh, no. I don't like this thing in here. Let me open it with another software. Yes. Let me open it with another software that is easy to handle these things. Images. Open with. Where is the open with? Open with. And let me get it with photo. Okay, this one has it's the same thing. Yeah, actually, the reason why you guys are looking at the same thing, and it is absolutely the same thing, because it's the same image, looking at it with two different resolutions, and one of them is actually here. So right now I'm transitioning to the other image. You would not notice any difference whatsoever, but one of them is 100K and the other one is almost 2 meg. Okay, one of them would fly through the upload, and the other one would really crawl through it. Okay, but you guys did not notice anything whatsoever in the two images. That is my point. I took the image with my phone at high resolution, then went to GIMP and I just set it to resizes. That's all. So it asks me which side it has. It was like 4,000 by something megapixels or pixels or whatever. So I told it, no, I just want it to be 800 or 600 on the width. It reduced the other one proportionally, and the image looks identical. Absolutely, there is no difference whatsoever. So it looks the same. So if I upload this one on Canvas, first of all, it doesn't take a lot of bandwidth, and then it looks the same. It works the same thing. So this is one of the things you're asked to do, is to show me just your setup to make sure that you're actually doing this. You're not doing something else or getting some data just from out of memory or out of somebody's else. Okay. So at some point, I will need a picture of your setup, and that is worth 2 points. You will need also the graph that is worth 2 points also. And you will answer the questions, which will bring me to the next topic. Is this clear, at least in terms of the picture, what is needed? Because some people will have question, what am I supposed to take pictures of? It doesn't matter, as long as you can show me what you're doing.
Yes.
Okay, so let's stop sharing the screen and let's go to the actual meaty part of this lab. Okay, let me go to let me open the PDF file first. Okay. Let me try to close it and open it because I don't understand. Okay, let me go into I closed it and I opened it again. And where is it? Where is the file? Here. No, that's Physics 11. That's not your class. What is the so many things open. I really need to be careful in here which one to share with you. I don't want to share with you something that that shows information of other students or anything like that. So, where is it? Okay, let me open it again, okay, because for some reason I'm having difficulty with this file in here, locating it. Lab1. Yeah, it's called Lab1. Okay, Lab01, Adobe Reader. Okay, so let me try to find it again. Lab1, here is Lab1. No, that's not. Where is it? So let me skim through every single one of these things in here to find it. That's not your class. Lab2 vectors, Lab1. No, that's not your class. Here, it's not showing the preview of the picture. Sharing this file may start a new window. Screen sharing has failed to start. The window you selected is invalid. Okay, so why is this thing giving us hard time? You guys were having problems with it, and now I'm having problems with sharing it. Okay. Can anybody see if they can open it? Because right now I'm having difficulty opening it, actually.
Opening the file for the lab.
Yes, and see if you can share it for with us. Because I don't want to close the whole thing just for it. Thank you. You have it open with Firefox or something? For us? Okay, let me open it with Firefox because I was doing it with Adobe and for some reason I'm having this thing, having problems with it, okay?
Yeah, I'm using Google.
I can
now.
open it, Professor.
Okay, hold on. I think I have it open too in here. Okay, very good. I think I have it open. You guys see it now?
Yes.
Okay, so that's the file. For some reason it was giving me a hard time, okay? So do you guys, when you open it, see that this is a highlight? Does everybody who were having difficulty saving it with this highlight thing or not? The one on the top. No?
Well, I said the file will not save, or the document will not save beyond.
And you opened it with the reader, Adobe Reader.
Yes.
You right-clicked on it and opened it with Adobe Reader.
Yes.
Okay, so that's strange. Anyway, the first thing.
But I used what Christopher shared through the messages. I can edit it now and save it.
Okay.
Hopefully.
Okay, so. Okay, so let's go through these instructions. Okay, forget about the technical issues, which hopefully we can solve them at some point, okay? Let's see if I can get this thing out of the way for me here. I know I minimized it. Let me make it a little bit bigger. Okay, because I have this screen in here. Okay, so basically, I want you to go through this introduction. The first thing I need, again, from you guys is your name, okay? That's why I have this field in here, which is a required field. Actually, when you see a red box around one of these fields, they are actually required fields. They are not like the blue ones in here. For example, this one has actually no boundary, or when you hover over it, it's going to give you this blue or dark border. This one actually is has a red border in here indicating that this is a required field, okay? You're going to go through this, read through it. Basically, the instruction is telling you we're going to get two kinds of clear tape in here. and we're going to make it in a specific shape. And if you follow the instructions, skip the objective for right now. Okay? Don't forget to include it though at the end, but skip it for right now. You're going to take the tape basically, and you're going to fold one end of it. So this end in here, I have it folded. That's to make it easier for me to handle it, okay? So that's one thing. This was charged, but there is a way actually for canceling the charge, and that is you rub through it and it's going to lose charge. But right now it's not charged. So you're going to make it, you want one end to be bent a little. And if you have markers, you're going to label it U. If you're not, then there is a problem with the marker, with the labeling. The reason why, because down the road, we will have a different version of one of this, and we will see their interactions. It's a good idea to have them labeled to know what's going on between each side, okay? If you cannot have it labeled, there is another technique, and that is take a colored paper and stick it to one end, okay? And say, for example, this paper that is yellow has specific minutes. It's U, and the paper that is white, for example, this is supposed to be yellow. Okay, what is my camera in here? Okay. Anyway, the point being in here is that that's another way of doing it if you don't have access to a marker. So now you have the two kinds. You have the first one. One of them, you're going to leave it permanently, and that's what the setup that I sent you the picture, at least I showed you the picture of it, my setup. So one of them is going to be there to use it as your charging station, and another one is to charge it and check with it and everything else. You need an access to an edge of a desk. If you don't have access to a desk, you can use your kitchen table, and it works perfectly fine for the purpose that we have in hand. As long as it's clear from the legs, because when I tried it earlier, at least when I was writing the instructions, I was very close from the legs, and the legs were interfering with my experiment. So if you stay away from the edge, from the legs of the table or the desk or something like that. Then you're going to follow the instructions and to do the pinch and basically handle it, and then you're going to pull it rapidly, and then you get your finger close from it, and you're going to note your observations basically from it, and you answer the question 1. Again, question 1, you have to be very accurate about it. You really have to do the activity, and you're going to note that. You will notice that there is a problem with it when you're moving it, and that is because your hand is probably interfering with it, so it's going to be either attracted or repelled to your hand. So try to do it quickly and put it there. In order to discharge one of them, and the instruction is in there, you have to rub your finger all the way up through it, basically, and that should clear whatever charges they are in there, okay? And then you can put it back. Are we clear here, at least roughly on this thing in here? I'm assuming that probably some of you had read it already because it was available early in the morning. Okay, 20 centimeters, 8 inch. You don't have to be using a ruler for this purpose in here and trying to get, as long as it's a size that is roughly this size, it should work fine, okay? So it should work fine. So there is a sticky side and there is a non-sticky side. The sticky side, of course, is where the stick parts of it, but when you're interfering, try to go from the other side, okay? And you should see the interactions happening in front of you. So that's question 1. So that's the standard process of making basically another we call them U and V tapes, okay? Because there is another kind that you need to make at the end. Because whatever charges there on one of them, you need to make the opposite using a different technique on the other one, okay? So the 2 U tapes. Now the first one was actually between you and between your finger and the U tape. That is one interaction. Then you have 2 U tapes. So we're going to make 2 of them now, okay? And you're going to observe their interactions. So we're going to make the first one, leave it hanging, and then bring another one. And you're going to check their interaction, okay? If U tapes are actually charged, how would you expect 2 U tapes to interact with each other, okay? Would you expect them to repel or attract one another? So now again, this is your expectation, okay? This is what you think will happen. And then at some point, you're going to prepare a second U tape, bring it near the first one, and eliminate the effects. Now describe the interaction. So the first one was really a prediction. The second one was actual observation. Okay. Please try to be accurate. And there is no wrong or right answer for the first one, but there is definitely a right answer to the second one. Okay. So the first one could be basically that I didn't expect them to interact, or I did expect them to interact. This is how I expect them to be. The second one will actually based on your actual observation if you did set up everything correctly. Now we're going to check the direction of the force, which way the force interacts, which way the force of the interaction points. Okay, either the forces, these are the two big assumptions basically. Either they are on the same line joining the two charges, two planes, or it's perpendicular to them. Any other angle doesn't make sense, okay? So one of the two is really the answer to that. So we want to eliminate one in favor of the other. So here is where the other thing comes into play now, where we hang them and basically try to bring them closer. I'm sorry, close as possible, and then see the effects of the direction of the force, okay? Which way is going to point. So that's basically how this thing is. So from there, you're going to tell me, is it this option or is it this option based on your observation where the force of the interaction is going to be, okay? When we do magnetism later on, you will see that this picture reverses for magnets. For this one, it's going to be the one way or the other. Again, this relies on you actually doing the activity. If you're having difficulty with this one, please communicate, let me know, okay? So that we at least work together through the activities. Forget about the technical things with the file, which we can resolve. Worst comes to worst, you can just refer to question 4 and answer it on a separate file, okay? So that's the worst thing I expect to have from you guys in terms of to circumvent all of those technical issues with this PDF files. Yes? So the main thing is focus on the activity itself and make sure you do that. So we have answered basically two key questions. First of all is that the type of interaction, attractive, repulsive or something. And then the other thing also we are answering in here is the direction of the force, which direction it is. We should be able to check that. Now we're going to explore the distance, the effect of the distance, if they are closer from one another or away from one another. Is it the interaction going to increase if I bring them closer, or the interaction going to decrease? Make sure that they stay away. You can't really go all the way to zero distance. So don't make them touch one another, because there are some other weird things that should happen. 2-point charges should not really be touching one another, okay? So we're going to stay from that. Don't make sure that they don't interact with one another. This is the graph I'm expecting you guys that you do by hand. Now, for some reason, again, you guys probably can click on this and see if you can upload the picture in here. I'm going to upload this picture. It's from another class, okay? So technically, this should work. I just uploaded the picture in here up to things in here together to this one in here. So for some reason, again, but that's fine. If you can't do this, just email me the picture, okay? Say the answer to the graph, okay? Here is the answer to the graph, and attach the picture with that, okay? Or upload it to Canvas, I should say, not necessarily email. Email is worst thing to do, okay? At the end, if everything else fails. Okay, so we have explored now conceptually graph how it's going to look like, or at least predicted how the graph would look like, and then we're going to actually do the actual activity. And I forgot probably to include the question for that. Oh, I'm sorry. This graph is actually based on your observations, okay? Based on your observation, but because we really don't have data to graph it on an Excel spreadsheet or anything like that, that's why it's a sketch, okay? That's why it's a sketch. Now, the amount of charge. This is the technique that, as I was saying earlier, and how much you're going to, basically, you have to hang it somewhere. I'm not, okay? You have to hang it somewhere and rub your finger through it until it discharges completely. Then it becomes non-interacting. Right now it's non-interacting. Discharge it, okay? So you can partially discharge it, not completely, okay? Because if you discharge it completely, it's not going to interact with anything. So that's the thing with it. Lower the charge in one of them and see the interaction, the effect of the amount of charge and how they interact, okay? This requires attention. This requires a little bit of patience with this thing, okay? The lab is supposed to last 3 hours. You're supposed to spend all of those 3 hours on this thing, doing them. And then usually there is an extra 1 hour, I mean, more, about 4 hours later for doing the reports. I expect you guys to be busy with this thing and make sure that everything works for you, okay? That you are 100% satisfied that the effect of the charge is important, okay? The more charge, the more the interaction will be significant, okay? So again, describe the changes in the CU interaction with your hand. So with another, so basically the effects of a charge. Okay, how much? What is that going to do? Okay. So at this point, we don't have quantities. We don't have numbers to say that we have this amount, but we can say there is more or less charge, because I can actually discharge it completely. But if I do partial discharge, then I have a rough idea that I did not have as much charge as I did before. Okay, so the effects will be different. Now, the last part is the interaction of the n-like charges. So there is a technique for making that. So you have to make actually two, in addition to the base, in addition to the one sitting on the bottom, you're going to make two of them now. One, which we're going to label U, and one which we're going to label V. Okay, again, that's where the color comes into play. Actually, we're going to make 4 at some point. Okay. And you make them, the two of them, you have to have, and by the way, when you're making them, make sure you press your finger around them so that there is no bumps or basically bubbles forming underneath, that they're as smooth as possible. And then you remove the two of them at once from the base. Okay, the base serve is only on making more and more if you like. Now, you remove the two of them from the base. And the first thing you do is use the previous technique in here to make sure that both of them are neutral. I mean, that the whole thing is neutral. That they are now don't have any charge whatsoever in them. Okay? The one in the bottom should be labeled one letter. The one on the top should be labeled another letter to keep track of them. Okay? Because you're going to make similar ones also. Okay? So that's why it's critical to label them in this order. So now you have two of them. With their labels in, you're going to remove the complete charge from them. When you separate them from one another, they will acquire charges. But because they are neutral altogether, so one of them will acquire a certain kind of charge, and the other one will acquire a different, opposite side of the charge. And they will be equal, actually, in magnitude. So both of them will have the same amount of charge, depending on how fast you pull them out. Don't pull them too slow, because if you pull them too slow, you're not building enough charge in it. So pull them together, and try to remember that when you make the second pair, so that you keep them all in the same ballpark, basically, in terms of charge. Now, you have one of them labeled U and one of them labeled V. Make similar to, again, U and V, because you will need 4, like I said, at some points in here. These are reusable, so if you did the first activities, you don't have to dispose of those. Just keep that. As long as it's still in good shape, you can still continue with it. Okay. So now you're going to do the in-like ones, the ones that are, you know for sure they are not the same, because you neutralize the pair. So the pair has no charge. When you separate them, you know one of them is one charge and one of them is a different charge. One of them is labeled U charge and one of them is labeled V tape. So one of them is behaving different than the other one. And you made another pair also similar to it, one of them with a U and one of them with a V. So now you have basically altogether 4. 2 of them of the same type, more or less the same charge. 2 of them of the same type, more or less the same charge. And you're going to do the in-like. Describe the partial neutralization. Remember how I called it earlier? That's part of the process again of learning how to do that. I'm not reading through this. I'm assuming, guys, you're going to read through this. I think I went a step further, actually. This is where we are right now. We made a U and a V, actually. So we're a step, or did I say V or an L? I'm sorry, L. Okay. I think I confused my letters in here too, so they need to be clarified. Okay. So I think the table calls you for something else. So I need to fix the table in here. Yeah, they're fine. Okay, so it's not a V, it's an L. Okay, sorry. So everything is fine, except remember that. I mean, I give them whatever names. Okay, as long as you have a consistency with the names, there's fine. Okay. Now you're ready to do the next activity, okay? If an L tape is indeed electrically charged and is charged unlike the U1, what interaction would you expect? And this is the prediction and this is the observation, okay? Again, similar to the previous activity, one of them is what you think might happen. Again, based on the hypothesis, we expect them to be this type of interaction. And based on the observation, what you actually have seen, okay? That is your conclusion. If we're sitting in the lab and we're doing it, actually, we're going to be more meticulous. We're going to actually see this together, see it work. I'm trusting that you guys are actually going to do this activity, and that's why I'm asking that you include a picture of your setup to convince me that you actually are doing these activities and not just relying on some common sense, well-known answers. Okay. Question 9: describe the static between different charges in terms of amount charged. Again. Now we have N-like charges. We're going to change the amount of charge on one of them and see the effect of that interaction again. Remember, we did it for the like charges. Now we're doing it for the N-like charges. And which brings me to the final table in here, which is table 1, which is basically you're going to tell me attract, repel in here based between the U and U, the L and U and L, based on your own observation. Okay? Based on what you have seen. Okay? The effects of the amount of charge between the U and U. Remember, you did that already. You partially discharged one of them and check the effects of the interaction. The electric force direction. Basically, is it along the line connecting the two or perpendicular to it between the U and the U? Again, remember, you have 4 of them, so you can do this, and the U and L. So pick any 2 and check this. And then the effects of distance, remember you did already the U and the U, and now we did also the U and the L, the 2 N-likes, and you bring them closer and further and see the effects of distance. So basically this summarizes everything in here. Based on that, you should be able to do this activity, the last one, which is the conclusion, okay? Based on that table, you're going to refer to this table based on this observation. The U and the U was this, the L and the L was this, and so on and so forth. So you have all of that. Now you have a clear idea what your objective was all along, which was to check this interaction between electrically charged, basically tapes, to prove or disprove whatever law that we've been exploring. So that's basically what the objective was. Now that the conclusion connects to that idea, except now you're referring to specific observations, which is based on this U and L. Does this make sense to you? At least the activities, forget about the technical issues like I said before.
Yes, sir.
Okay, so I expect that you guys start starting on these things in here. And should you run into some difficulty, please let me know. Okay. Make sure the room is not humid. I mean, California is not a problem in here where we are right now, so it's not the problem. So if you have a problem being discharged too quickly or something, maybe you have your hand too long in contact with it. Try to be careful with that, okay? So try to have as clear as possible area for your working thing for this one in here. And you should have fun with this. You should actually have no problem with it. Okay? Actually, you are encouraged. This question is from Jacob, and he's asking, can we work together? Absolutely, yes. Yes, you can work together, except you cannot be physically together. This is against the ordinance of the county and the state and all of that. We don't want that, okay? So you can work together, but your own setup may be different than somebody else's setup. You can discuss the results. You can discuss the hypothesis. You can discuss what things, but your own wording is your own wording. Furthermore, should you choose to work with somebody, I need to know who that person is. One or more than one person can work together, so I need to know who you worked with. I don't want to find similar answers, identical stuff, and then at the end, I don't know that. I mean, I would assume that probably one of you guys got a hand on somebody else's work and they copied it, and that is not good for either, because the person who was not careful enough and had his work basically with somebody else, that's not good. Now, all of your answers should not be identical, though. At least the verbiage should not be the same. You may have worked together, but your own conclusion is your own conclusion, your own words, basically. It may be similar conclusions in the sense that you're arriving to the same results, but your words are different than anybody's else. Same thing. Your hypothesis should be not the same. Okay, your things should not be identical in the sense that there is things to distinguish one from the other. Now, down the road, we will have simulations. Each and every one of you will have his or her own data, which means that even if you work together, there can never be two, for example, calculations of the error being the same or calculations of the same averages being the same number, because your data will be actually different. They're not going to be the same. If you're going to work together, and if you want me to facilitate that through Zoom or anywhere else, I'd be more than happy to do that. But I need to be aware of that, because I don't want any surprises when I'm grading this thing to see, oh, this sounds familiar. This looks like somebody's else. Okay, and both of you lose points unnecessarily that way. I need to be aware of that, okay? In the comments of the submission, when you submit it, I worked with so-and-so, or I worked with so-and-so and so-and-so, so that it's clear, okay, that it's your submission, it's your work, but you had to work together. You look at any paper in physics now, or any subject for that matter, you'll find a bunch of names working together on the same topic. And that's perfectly legitimate, and actually you're encouraged to do it. Okay? Any other question? That's a good question, Jacob. Anyone else has a question? Okay, I'm sure when you start working on this, you're going to discover some issues with it, other than this thing, which I'm going to try to fix right away. And I probably will communicate with you guys and ask you to tell me if it's fixed itself or not, okay? Okay, I will see you guys on Wednesday at 12:45. And when we meet there, we're going to finish chapter 22 and hopefully do one or more problems from the chapter book, okay? And we will also get next week into chapter 23. And don't forget, you have homework on Canvas. You have also homework on mastering physics. And don't forget also the assignments after this class is in here. After this lab, there is probably one question which I'm going to ask, and it should be easy enough. If you read the instructions, it should be in the instructions itself. Okay, it should not be hard to answer, and that's going to be actually submitted for this specific purpose in here, for actually the participation in the lab. Does it sound good?
Yes, Professor.
Okay, passion, everybody else is good. So, if you guys don't have any questions, I'll see you. Okay, of course, part of what we're left with is that you guys work on the lab, because we still have time for the lab to finish it, okay? Okay, I'll see you Wednesday, guys.